In this video, we're going to discuss VLANs, VLAN pooling, and DHCP services within Ruckus 1. Here we are back again in our Ruckus 1 instance. At the most basic level, the VLAN can be assigned to a WLAN, and we can see that in an example. If we go over to Wi-Fi and Wi-Fi network list, and we look at our Arena WLAN here, we can see all the way on the right VLAN 20 is listed. If we drill down further into it and go to Configure, clicking on More Settings, we can see the VLAN ID is defined here. Now, to make this work, we need to make sure that our AP ports are also configured to support these VLANs. Best practice is to define the AP VLANs at the venue level through AP model-specific configurations. However, it is important to understand that these venue-level settings can be overridden at a per AP level. When troubleshooting VLAN inconsistencies, the administrator needs to understand the venue defaults and investigate for any individual AP overrides that could contribute to mismatched VLANs. We are going to look at our venue here. We go into the Home Network and click on Configure, then Wi-Fi configuration so we can look at some of the actual AP configurations. Clicking over on the Networking tab, we can see here we've got LAN ports, and we can change or look at our model-specific settings. When determining VLAN support at an AP level, it is important to understand that APs with a single Ethernet port will have that port automatically set to trunk, which cannot be changed. Single port APs use the port as their VLAN uplink, and it is tagged for all VLANs to support any management or WLAN configurations where alternate VLANs are used. Many of our APs have multiple Ethernet ports. For these APs, one port is designated as the VLAN uplink. Depending on the AP model, you can modify the port type of the uplink, although it defaults to the trunk type. The designated uplink for multi-port APs is the PoE input port, and it cannot be disabled. You can fully configure any port other than the uplink. Typically, you should configure these ports to either allow specific VLANs or disable the ports completely for security. Any port, including the uplink, can be configured as access, general, or trunk port type. The trunk port type is applied by default to VLAN uplinks on all APs. However, as mentioned previously, APs with a single port cannot have their port type modified. The trunk type allows for all tagged VLANs. Ports with the access configuration have one untagged VLAN configured. You would use this port type to restrict client or device access within the network. For example, consider an H-series AP deployed within a hospitality environment with some of its 4 ports utilized by a phone or TV, which may be directly connected to their own VLAN. The TV port can be configured as an access port, restricted to the VLAN the administrator has assigned. The general port type functions similarly to trunk. However, instead of allowing all VLANs, the general port can be configured to a smaller subset of tagged VLANs, restricting the AP to only what is required. This configuration limits the available VLANs and increases security. Any additional AP port that is not actively utilized should be disabled. Now that we have discussed VLANs from a venue and AP perspective, we need to address the switch configuration as well. A mismatch at any point in the path will result in problems. If you are managing your switch environment in Ruckus 1, you can create VLAN configurations and check existing VLAN configurations. Navigate to Wired, then Switch List, and select a specific switch. Under the VLANs tab, you can see the list of VLANs configured on the switch, as well as the untagged and tagged status per port. To confirm which port your AP is connected to, go to the Clients tab and look for the specific AP, which will be shown by name and MAC address. So far, we have discussed how VLANs can be applied, and that VLAN configurations must match across the WLAN, AP, and switch configurations. In the previous example, we showed a WLAN with a single VLAN. It is also possible to have multiple WLANs, each with its own VLAN. However, this does not scale well. In the case of a WLAN servicing many clients, such as in an arena, large conference hall, or college campus, using one WLAN with one VLAN or even multiple WLANs with their own single VLAN is not efficient. Instead, we can use VLAN pooling. A VLAN pool is a grouping of multiple VLANs presented to the WLAN as a single entity. We use VLAN pools to scale our WLANs to support the number of clients needed in larger networks and to avoid having a large Layer 2 broadcast domain. Let's look at how this works. We go over to Network Control, then Policies and Profiles, then choose VLAN pools. We have a VLAN pool that is configured for VLANs 2, 30, 40, and 50. We can then specify within our WLAN to utilize this VLAN pool. Let's go back to our Wi-Fi networks, so we can apply our VLAN pool to a Wi-Fi network. If we choose our test WLAN, go over to Configure, then More Settings, we can see this toggle here to turn on VLAN pooling. Then from the drop-down, select any of the pre-configured pools or optionally add a pool here. Once we're happy with the configurations and we've got the VLAN pool defined, we can go ahead and choose Apply to apply these changes to the WLAN. The WLAN with the VLAN pool specified will now direct users to one of those VLANs based on a hash of their MAC address. The benefit of this approach is that you do not need to create a large subnet to meet the demand for the number of clients, nor will you overwhelm a single broadcast domain. When using VLAN pooling, all previously discussed requirements for proper VLAN configuration from the VLAN uplink port perspective still apply. Additionally, you must configure the VLANs in the pool on the WLAN, AP, and switch. APs can also inherit port settings specific to the AP model from the venue, so this should also be considered during configuration. Let's look at the DHCP services offered within Ruckus One. Ruckus One allows APs to perform their own DHCP services. You can choose from multiple DHCP configuration options, each offering its own implementation of both DHCP and NAT. We can go over to Network Control, then My Services, and select DHCP for Wi-Fi. Now we've got a DHCP service already defined, but if we wanted to add more, we could do that from Add DHCP Service. Here you can provide the service name, DHCP configuration, and also add a DHCP pool. If we click Add DHCP Pool, we can add details for pool name, subnet address, subnet mask, start and end address, as well as primary and secondary DNS, lease time, and VLAN. Before choosing one of these options, the administrator should understand where services are currently deployed in the network. If there are DHCP or NAT services deployed, it is critical to understand the impact on the network when using DHCP for Wi-Fi services. NAT is enabled automatically and cannot be disabled when DHCP for Wi-Fi services are used. In our existing DHCP service, we have 4 DHCP pools already added, and it is not activated yet on any venue. We can choose it and click Edit if we want to make any changes. Let's open this DHCP service and look at its details. So in the overview, we can see the number of pools and the details of the venue using this service. If we select the DHCP Pool tab, we can see the pool details. So we've got VLANs 2, 30, 40, 50. We've got subnet address and mask, the ranges specified for all those pools, etc. Once the DHCP service profile has been configured, we need to apply it to the venue. Let's see where it's done in our environment. So we can go over to Venues here. We specify the venue where we need to apply these DHCP service profiles. go to the Services tab and click on the DHCP tab. Then click Manage Local Services and turn on Service State. Then from the drop-down that appears, select DHCP Service and click Apply. When the settings get applied, the page will get populated with the DHCP service details. It is important to know that DHCP for Wi-Fi services, once created, is applied at the venue level and cannot be disabled per WLAN. Additionally, if NAT is utilized upstream in the environment, double NATing will add complexity to situations when IP port forwarding is required. Ruckus One does have the ability to perform Layer 3 forwarding, as we will show within the Advanced WLAN Settings video. If we're using DHCP service profiles along with VLAN pooling, we just need to make sure that our VLANs are aligned. If we had a VLAN pool configuration that included 2, 30, 40, and 50, but didn't include VLAN 50 in the DHCP pool, then that would be an issue for any clients that were placed into the VLAN 50 pool. You need to ensure that any VLANs in the pool are represented in the DHCP profile and are properly configured on the AP and switch configurations. We've got enough coverage on the DHCP service profiles for all of the VLANs that we've configured in the pool. The last thing to mention is that we cannot enable DHCP services on a venue where mesh APs are residing. If we go over to Venues and we look at Play, then go to Services, we can see that it is currently off and we're unable to click on it. If we hover over here, it will say we cannot activate the DHCP service on this venue because it's already enabling mesh settings. So if we've got a venue with mesh, we are not going to be able to use the DHCP services on that venue. We covered a lot of information in a short amount of time, but hopefully this gave an idea of what to look at when dealing with issues with the VLAN pool or DHCP service.